All right, boys and girls, let's do some quadratic parent function stuff. Hopefully you've learned from Algebra 2 that the equation is y equals x squared. I can't write, sorry about that. Let's try that one more time. Y equals x squared. If we square x, negative 2 squared is 4, negative 1 squared, blah, 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 blah. Hopefully you know that by now. And so then our picture looks something like this. Now remember, it's symmetrical over here, so it's going to look exactly the same. Boom, just like that. The next part is for you to write down right there. Go ahead and pause it, write that down, and I'll talk about it. The standard form of quadratic parent function and the vertex, just a little different way to write the same information. First thing is both of them, if A is positive, it's up like a cup. So if it helps you to write that down, up like a cup. And then if A is negative, it's down like a frown. Down like a frown. Next thing, axis symmetry. You're just plugging in AB into this right here. For the axis symmetry of this, it's literally just that value. And we'll get more into this in a second. Vertex, I don't want to talk about with standard form, but it's that. It's kind of messy, but we find this, plug this number in for Y, get that. And then lastly, vertex is just H comma K. And mind your minuses and your plus. One last thing, if it's a minimum, it opens up. So it's got that minimum value, and then if it's maximum, if it's down, it has a maximum, and that goes for the same thing there and there. You can only have one of these. You can only have both. It's either a min or a max. Let's do a couple of these. The calculator is pretty beneficial, so if you have a calculator, go and plug that in there. We should be able to tell that it's concavity because it's positive is going to be up. So I'm going to draw a picture there. Axis symmetry is going to be x equals negative b over 2a. So negative 4 is positive 4 over 1. So, over 2 times 1. So that means my axis of symmetry is at 2. Now remember, axis of symmetry just cuts my graph in half, and it makes it symmetrical. So whatever's on here is going to be on here. Next thing is my vertex. I'm going to take my magic number 2 and plug it in. So I get 2 squared minus 4 times 2 plus 5. So I get 4 minus 8 plus 5. That's going to give me 1. So my vertex is at 2 comma 1. Last thing, since it's up like a cup, that means I have a minimum value. From here, go ahead and plug in our numbers and graph it. You probably need 3 or 4 more points to make it exact. And let's see if I have a good version of this. Let's see here. There we go. Should look something like that. Okay. Number 2, so I'm going to flash back here. Number 2 is in vertex form. So we look to see first, okay, matching up vertex form, match our table, all that. My A is negative, so that means it's going to be down. It means it has a maximum point. Next thing I want to do is my vertex. Vertex is this. It's going to be 2 comma negative 1. I know it's kind of weird. Even though I got a minus sign there, it's still positive 2. I did not make a mistake there. And then lastly, my axis symmetry is this value, so x equals 2. Go ahead and put that in your calculator. Go ahead and plot your vertex. So 2 comma negative 1. Axis symmetry goes there. And once again, we want 2 or 3 values. So let's see if I can find a good picture.
Basketball team or SOAR.
Sorry about Mr. Bruner. There it is. Got all of our values there, drawn upside down. Boom, boom, boom. Next one. You know, all these kind of work the same way. If you haven't, I'll go ahead and give you the answers. You can check it. I don't really know if they're worth doing. Good grief, what am I trying to do? Oh yeah, there we go. So there's that one. We got it up like a cup. Axis is at negative 3. My y-intercept is 0,7.5. This isn't really drawn. I think something happened when I moved my computer. If I were to move this over just a little bit. There we go. That's right. And then talk about domain and range. My domain is all real numbers. Range, everything bigger than negative 6. Or you could say all real numbers for domain and then negative 6 to 0. And then here's my next one. You know, it's in standard forms. Things are a little different. Once again, something screwed up here with my graph, but I'll go ahead and try and fix that best of my ability. Let's see. Yeah, that's about right. It should be at negative 1.5 comma 4. Y-intercept is down at negative 5. Domain, all real numbers, range, everything smaller than 4. And then the last couple were kind of easy and quick. Number 5, you plot the point, 2 comma 3. And once again, gosh darn it, screwed up. 2 comma 3. 2 comma 3 goes right there. 6, 9 is right there. And so we see that it's up like a cup because if this is the lowest point, this is another point that's symmetrical. And the last one, finding the mixer minimum maximum, just put that in our calculator. One thing I will show you on the calculator is that if that's number, the last one, 5 or 6 or whatever it was, 6, I can use the calculator to help me out. So I'm going to press second. Well, once I finally got y equals done. So I got y equals all done. I'm going to do second trace. Has a maximum by me just knowing what the picture looks like. And I'm going to go to the left of it because that's what the calculator is asking for. Press enter. I'm going to go to the right of it now. Your calculator probably won't give you those dashed lines, and that's okay. Then just press enter. It can be wherever you want as long as it's to the right of it. And then go ahead and guess. And then the calculator is going to give me that. And then that's how I got that negative. That's not even right. Wow. Terrible. Negative 0.75 comma 5.125. All right. Anywho, that's that. Let me know if you have any questions. See you in tutoring. Bye.